Let's continue on with a few more details about binary numbers. Let's talk about what's big and what's little. Now, I once made the comment at home, bouncing off of my two math type people who lived in the house. I really get confused about why negative 232 is bigger than negative 255. And this is rather interesting because when you go to take your next course, or at least when I took C++, the people who did really well on the exams and in the course were the math and engineering majors. These people get numbers. So here I am making this comment, and I get, well, Mom, well, Mary, just think of your number line. Gave me a little insight into maybe mathematicians do draw pictures even though they think abstractly. Maybe the rest of us could learn something from them. So, sure enough, you draw the number line, and if you are moving to the right, the number is bigger than any number on the left. So now just imagine where the 232 would be and the 255, negative, that is. So negative 255 would be to the left of 232, so it's smaller. I went, oh, duh, because then it made it more clear to me. So if you have a little trouble with this, then draw the number on a number line, position your numbers, and go through the principles. If it's on the left, it's smaller. If it's on the right, it's bigger. Repeat it enough times and you'll believe it. Now, we're going to take a look at the numbers that are closest to 0 and furthest from 0 on the negative side. So obviously a negative 1 is closest to 0 and the negative 32,000 is farthest. So the number that's closest to 0 on the number line looks like this. Whoa, does that look like a negative 1? No, let's flip the bits. Let's add 1. Comes up with the same answer. So it turns out when we have all the bits on, electricity flowing through all of them, that's a negative 1 in base 10, the equivalent. How about the number that's farthest from 0? Well, here's what it would look like in binary. The smallest negative number has a 1 in the sign position on the far left, and then it's followed by no electricity going through. So I'm going to flip the bits, add 1. Every single one of these is 0, carry 1, 0, carry 1. So blah, 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 blah. And I get the same original answer I had. And if you carry these out, it's the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2 to the 15th power is, 32,768. So that particular number is negative 32,768. So negative 32,768 is the smallest negative number. Then you have 0. And then plus 32,767 is the largest positive number. And it always kind of bothered me. It's like, oh, why aren't they the same? Well, we do have an equal number of digits, or integers, I'm sorry, because you've got to add 0 into this thing. So it kind of works on the positive side. So you really do have 32,768 numbers that are not negative. So the total number of integers is double that number, which is 65,000 something. Okay, I've got a whole bunch of exercises for you to do so you get practice with this. We'll demo them in the next module. But there are 7 different exercises. The first set 1, 2, and 3, they take a positive binary number and convert it to base 10. They start out, each one has more bits that are turned on. That's how it works. 4 and 5 convert it to negative, so you're going to have to flip the bits and add 1 there. And the third set, which is number 6, it's grouped with 4 and 5. It takes negative and turns it back to positives. Again, you'll have to flip the bits and add 1. The fourth set, number 7, converts binary negative to base 10. You're going to have to flip the bits, add 1, and convert it in order to get it out. This will most closely resemble the exam that you will have. Just pull up Blackboard for a moment here. And this is the teacher view of it. But there's the binary 1, 2, 3. Those are the ones that just convert it to base 10. And then 4, 5, and 6 work with the negative numbers. And then 7 has negative numbers and you have to convert them to base 10. So that concludes this part. In the next session, we'll work through a few examples in some of the files so that